So what I'm going to do in this video is show you how ARP works. ARP is a protocol that's really foundational to network communications. The purpose of ARP is to resolve a next hop MAC address. There's automatic ARP, and there's also as a result of network traffic. Now with automatic ARP, anytime a network device starts up, it'll actually get the MAC addresses of the next hop neighbor automatically. And it will build that table automatically, and you'll note I'll show you how this works. There's also when I send a ping or start a web page, that's another type that's triggered by that network traffic to start populating the ARP table with the MAC address needed for setting up that communication between source and destination. What I'll do is I'll show you the ARP tables currently as they exist without any network traffic. So I'll go to the layer 2 switch, and I'll just show you that layer 2 switches don't have an ARP table. Nothing there. I'll go to R1 here, use the same command, show IP ARP. You can see that this is populated already before any traffic has been sent. So you note there's 5 entries with this ARP table. 3 of them are actually belong to the local interfaces on R1. The 192.168.1.254, that's actually gig 002 right there. And then you've got these other 2 interfaces, 000 and 001. Now 000 is 192.168.2.1, and the neighbor on R3, gig 000, that's 2.2. The same here on gig 001, this is 192.168.3.1, and on R2, 001, it's 192.168.3.2. That's where the other 2 are sourced from. So 2.2 and 3.2 are actually advertised from a neighbor. There's the age there, 3 minutes. That's because it's advertised. The other ones are local, so they don't have any age on them. And these are the local interfaces where this was learned from. So 192.168.1.254, that's gig 002, for instance. That's actually a local interface. So the ones that are advertised from R2 and R3, this is 000 and 001. That's where it's actually learning it from. So that's the start of the ARP table. Then I'll go to layer 3 switch here. I'll do show IP ARP. Since it's a layer 3 switch, it does have an ARP table. And it has the same thing as well. It's got 172.16.2, 3, and 4.254. These are gateway addresses. They're called SPIs, VLAN interfaces that are configured on the layer 3 switch. They're actually default gateway interfaces. So they're local interfaces. And the 172.16.1 and 2, the 1.2 is local because it's got no age. And the 1.1, 172.16.1.1, this is the R2 that's advertised. That's the IP address of gig 002 on R2. Now I'm going to do is I'm going to start a ping from host 1 to 172.16.2.1 to generate some traffic. So that works okay. Now we'll look at the MAC address table on the layer 2 switch. And you can see there's gig 01. It's in there because that's where I sent the ping from. I'll show you IP ARP, and there's no ARP table here, just to show you that. See, nothing, because they don't support ARP tables. And I'll go to the layer 3 switch here, show IP ARP. So the only new one that I've got there is this 2.1, and that's VLAN 100, and that is the HTTP server. So it's got the MAC address of the HTTP server there, and also the VLAN assignment, VLAN 100. So what happened is host 1 sent a ping to the HTTP server, and what happens is HTTP server returned its MAC address to the layer 3 switch. So now it's actually in the layer 3 switch. It doesn't go any further than that, but it's there so that when the actual ping arrives, the layer 3 switch will know how to do the addressing. So 2 things happen then. First thing is that the web server responds with its MAC address. So what happens is in the layer 3 switch, that gets installed into the MAC address table There's also an ARP table entry as well that associates the IP address with the MAC address, and that's used for addressing as well. Since all layer 3 devices, whether it's a router or a layer 3 switch, will do the addressing both MAC address and IP address. We'll go to host 1 as well. The thing that ARP does is it creates an ARP tree in the host for the host. So ARP/A. So you notice here it's got the MAC address of the default gateway. So this is the other part that ARP does. It finds the MAC address of the default gateway so it can actually start addressing. So this MAC address becomes the destination MAC address for all traffic outside the local subnet. It goes right to the default gateway, that's R1, and then R1 will do the routing and send it off to the remote location, to the remote subnet. So there it is, there 192.168.1.254, and there's the destination MAC address. When your packet's leaving host 1, the source IP address would be 192.168.1.1. The destination IP address would be 172.16.2.1, and that doesn't change per hop between source and destination. It's only the MAC address that changes as it hops between different layer 3 devices, whether it's a router or a layer 3 switch. And from host 1, the source MAC address would be the MAC address of the network adapter, and the destination MAC address would be this gig002 MAC address. That's what I just showed right here, that physical address. As soon as it gets to R1, the IP address will stay the same, but the MAC address will be rewritten. So the source MAC address will be the MAC address of gig001 on R1. The destination MAC address will be the MAC address of gig001 on R2. So it keeps changing this MAC address per hop. So that's how ARP works, and that concludes the lab.